Hello guys, this is Jitenjan and this is our 8th signal and system lecture. In last lecture, we have discussed about ordinary convolution, which is also known as linear convolution. In this lecture, we will see periodic convolution or circular convolution. Both are same, periodic or circular convolution. So what is difference between ordinary convolution and periodic convolution? So suppose we have two discrete signals, x1 of n and x2 of n, and x1 of n consists n1 number of samples and x2 of n consists n2 number of samples. So the ordinary convolution of these two signals will have n1 plus n2 minus 1 number of samples, while periodic convolution of these two signals uh, will have number of samples equal to maximum of n1 and n2. Okay, whatever the maximum value among between the n1 and n2 will be the number of samples in the periodic convolution of these two signals. Okay, so number of samples in both convolution is different. Here n1 plus n2 minus 1, and here maximum of n1 and n2. Suppose we have one problem that find periodic or circular convolution of two signals xp of n and hp of n. Both are given. So what is procedure to find circular convolution? It is very simple. First of all, you write here xp of n, then hp of n. Okay, here the number of samples is n1 equal to 4, here n2 equal to 4. So first of all, you have to find ordinary convolution. In previous lecture, I have already told you that what is procedure to find ordinary convolution. There are two methods. You can use either array method or some sliding strip method, or you can use sum by column method. So sum by column method is easy, so you can choose sum by column method. What you have to do, first of all, you have to multiply 1 with all elements, you have to write below, then you have to multiply 2 with all elements, and you have to slide by one position to the right side and again right. Similarly, you have to slide one more. Okay, then you have to add all the so you have to add sum by column, you have to sum by column. Okay, the by the name it is clear. Okay, so 1 will be here, then 1 into 2 plus 2 into 1, 2 to 4. Okay, like this you will get ordinary convolution like this. So the and we know that circular convolution will have number of samples maximum of n1 and n2. Okay, so here n1 is 4, n2 is 4, so maximum of 4 and 4 is 4. So you have to choose 4 samples from here, 1 2 3 4, and then remaining elements you have to write below. Okay, and left, if the position is left, you have to write here 0. You have to add this 2, so you will get like this. So you will get circular convolution like this. So what is circular convolution? Circular convolution is sum of ordinary convolution and aliasing. Okay, linear convolution plus aliasing is the periodic convolution. Okay, so this was the one method which can be used using the ordinary or linear convolution. First of all, you have to find linear convolution, but there is another method in which you can direct find circular convolution. So second method is matrix method. So here you have to write, so first of all, first signal x of n column wise 1 2 3 4. Okay, x of n is 1 2 3 4 now. Yeah, so you have to write 1 2 3 4 column wise. Then again you have to rotate 4 here and slide by 1 downward, 1 2 3. Okay, again 3 will be 3 will be in the top, then again slide 4 to here, 1 to here, 3 to here. Okay, so how much rotation you have to do? It depends on h of n or second signal. If second signal consists here 4 samples, 4 number of samples, so you have to rotate, you have to take 4 columns, so that the both multiplication will be means will be justified. Okay, Okay, so number of number of samples equal to, you have to means so you have to take a number of columns equal to number of samples in another signal, so that the column in first matrix will be equal to row number of rows in second matrix, and multiplication will be periodic convolution. It is easy. So matrix method is more preferable than the ordinary convolution method. Next problem is given x equal to, first signal is ABCD as the input to the an LTI system produces an output y equal to x. It is not x1, this is comma, so x repeated n times. The impulse response of the system, you have to find impulse response. How you will find? First of all, you write x value here, so x ABCD, so y equal to ABCD. Okay, so it is repeated n times, so you can write in terms of summation here also. Okay, so what is impulse, what will be impulse here? Means here input is repeated n times. Okay, so this is, you can write here del of n, sorry, not x, you can write here x. Okay, ABCD is x, you can write here x, and again here what is it is x n minus 4, it is shifted by 4 na, that's why x n minus 4 x n minus 8. So with this all x, all shifted x, what you have to convolve with the signal, you have to convolve with the impulse response, then you will get y na. So you have to convolve x with h, then you will get y. So what will be h? First of all, h will be, for this sample h will be del of n, then you will get x as output, plus for xn minus 4 you have to convolve x with del n minus 4, so that you will get xn minus 4. Again for xn minus 8 you have to convolve x with del n minus 8. So like this you will take h equal to sum of del n plus del n minus 4, then you will write it into terms of summation. Okay, so next problem is y equal to e to power minus t u of t convolve with summation del t minus 3k minus infinity to plus infinity, such that y of t is a e to power minus t for the range of t 0 less equal to t less than 3. Find a. We have to find a here. So how we will find? First of all, you have to write yt here, and you expand this summation. Okay, then yt, then convolve it. Okay, so if you convolve this two, means as we know the impulse function property, if we convolve this with del t plus 4 plus 6, so instead of t you have to write t plus 6. Okay, like this. Okay, similarly all will be done. So what we have to find yt bit for this range 0 less, so t always greater equal to 0, so this is t plus u of t plus 6 means before t equal to 0 point, so this will be 1, this will be 1, this will be 1, and t minus 3 means t equal to t equal to 3 onwards it will be 1, but we have to take t less than 3 na, that's why it will be 0, it will be 0. So what you will get? You will get e to power minus t plus 6 e to power minus t plus 3 plus e to power minus t summation, like this. Okay, okay, now you take e to power minus t common here, and you will get here 1 plus e to power minus 3 plus e to power minus 6, and e to power minus t will be cancelled, so a equal to this, and this is GP series, geometric progression, so its sum will be a upon 1 minus r. Okay, so you will get a like this. Okay, next question is, suppose for an LTI system if the input applied is del n minus 1, the output is observed to be del n minus you means you have given input and you have given output for that input also. You have to find another output for the another input. You can find it. What you can do, you have given y for given x, you have given output for given input, so you can find transfer function h of z. For this input you can find output y of z equal to h of z into x of z. For that, using z transform you can find you, but till now we had didn't studied z transform, that's why we will not use here z transform. We can use signals transformation properties, like input is this, then the output is this. Okay, for this input you have given this output. If you find if you uh, if you find this input using this input, means if you transform this input with this another signal, means you can, if you calculate this input, or you can I could say that if you transform this signal into this signal, then the corresponding output will you can find using transformation properties. Okay, so x1 of n given, so you have to find x2 of n using x1 of n. What you can do, first of all you shift x1 of n by 1 to the right side, then you add these two signals, you will get this x2 of n multiplied by 7, you have to multiply by 7. Okay, so first of all you find output due to this, then you multiply by 7, you will get. Okay, so due to x of n you find the output like this. This is actually x1 of n, this is x1 of n. Okay, so due to x1 of n you got output y1 of n, so you have to find y2 of n, means you have to find output due to this input. So output due to this input is nothing but output due to this input, and output due to x1 of n plus output due to x1 of n minus n and 1. So okay, you can find output due to x1 of n is y1 of n, and output due to this is the y1 n minus 1. Okay, you have to multiply with 7 because here extra term is 7. Okay, you can find it. So next topic is properties of LTI systems. What is properties of LTI system? Linear time invariant system. So each LTI systems are causal systems. So what is causal system? If before a system is called before causal, if before the application of input, the before the application of input as impulse at n is equal to 0, we cannot get output as impulse response. Means what is impulse response? Impulse response is the output or response due to the input as impulse. So a causal system will be causal if h of n will be 0 for n less than 0, or in continuous h of t is equal to 0 for t less than 0. Okay, so both discrete continuous properties are same. Okay, so our system will be causal if h of t will be 0 or h of n will be 0 for n less than 0. You have to remember this. So what is stable system? A system will be stable if the corresponding impulse response should be absolutely integrable, means summation in n equal to minus infinite to plus infinite mod h of n should be less than infinite. Okay, there is proof also, you can find, you can do by your own, it is very easy. Okay, so you, okay, this is very easy property, you can remember this. So third property is static or memoryless system. Each LTI system is causal. Okay, each LTI system is causal and static and okay, and stable. So what is static system? Static or memoryless? Sorry, LTI system may be static or memoryless. Okay, and LTI system may. Okay, so what is static system? So system will be static if the impulse response is the is in the form of k into del of t. Means impulse response should be 0 for all non-zero time. Means for all t not equal to 0, impulse response should be 0. It should be non-zero only at t equal to 0. Okay, so using this, what you can conclude that You remember, causal system will be h of t should be 0 for t less than 0, and for static system h of t should be 0 for all t non equal to 0. So all static systems are causal system. Okay, you can conclude here. Okay, but all causal systems are not static. Okay, now um so all property indicate in internal behavior of the system. So next problem is h of t is equal to e to the power minus t u of t plus 2. You have to find whether the system is causal or non-causal, stable or unstable. So you can find, because this h of t, you have to first draw h of t. So this is non-zero for t less than 0. That's why system is non-causal, because it should be 0 for t less than 0. Okay, for to be causal. Second, stability, you have to find the absolutely integration of this h of t. If it is finite, this is finite, so its system will be stable. Similarly, all questions are simple based on the stability and causality. Okay, this is somewhat new. The range of a and b for the impulse response h of n is equal to 8 for n b for n greater equal to 0, bit for n for n less than 0. So आपको a and b, you have to find a and b for the system to be stable. What should be a and b? So to be stable, the you know the condition, integration minus infinity to plus infinity mod h of t dt. You can draw like this. Okay. Oh, you don't need to consider here alpha and beta like I consider here. You can find directly. What you have to do, you have to absolutely integrate that h of t, put here a and here b, minus a minus b. Okay, okay, sorry, alpha and beta, no, put here alpha and beta. Then you know that for t less than 0, you have to take this signal will be 0, and for t greater than 0, this will be 0. So if you solve that, you will get, it is easy. I done by different method. This is complex, you don't need to do this. Then you will find two GP series. Okay, and you know that infinite GP series solution sum will be a upon 1 minus r, where mod r should be less than 1. Okay, here that property will be useful here, mod r should be less than 1. So here you will get answer. You please you do your by own, and if you got any doubt, please comment me in the comment box, so that I will help you. So you will get answer, mod a should be less than 1 using GP series, and mod b greater than 1. Okay, for the system to be stable. So next property is, if two blocks in series, two systems in series, h1 of n and h2 of n, so equivalent block will be h1 of n convolve with h2 of n. If two blocks in parallel, the impulse response will be added. So next problem is based on the series and parallel combination of the system. This you can do by your own. This is nothing but 1, impulse response is 1, or the del of n you can write, and this is h1 of n, this is h2. So this will be added, then in series, that's why both will be in convolution. So del of n plus beta del n minus 1. Okay, convolution with this is 2 of n. Convolve this, that impulse function property will be useful everywhere. That's why I already told you that property. Is this system causal? Under what condition the system is stable? Okay, we have to find the causality and stability of that system, and to be system stable, what should be the condition? Means you have to find alpha and beta's value. Similar thing is you can do by your own. Okay, so you will get answer, mod alpha less than 1, then the system is stable, a system is causal. So next problem is for the interconnected system shown in figure, find the overall impulse function. You find your h1 of n, your h2 of n, convolve these two, you will get h of n. How you will find here h1 of n? What is h of n? H of n is impulse response due to impulse as input. So if you apply input as impulse function, you will get output as impulse response. Okay, so put here del of n and here del n minus 1, you will get h1 of n. Okay, and convolve with this 2h, you will get h of n. So your what is invertible system? Sorry, we already discussed causality, stability, and system, static system, dynamic system. And what is invertible? Okay, what is invertible? Okay, for static system, if the impulse response is consist difference or in continuous we call it differentiation, and in discrete we call it difference, then the system will be dynamic. Okay. So next property of system is invertible or non-invertible. So what is invertible system? Lti system is invertible system. What is invertible? H of n convolution with h inverse of n is equal to del of n. This should be satisfied. Means if you take in Z transform domain, that Z domain, h1 of z into h2 of z should be equal to 1. Means h2 of z is nothing but 1 upon h1 of z. Means h2 of z should be inverse of h1 of z. So multiplication transform into convolution in time domain, that's why h of n convolve with h inverse of n should be equal to del of n. Okay, so consider the discrete time system with impulse response. This find a such that this should be satisfied. Okay, so put here h of n and h of n minus 1 and solve it. Okay, you will get like this. Then you take common from both 1 by 5 to the power n, you will get u of n minus a into 5 into h of n minus 1. Sorry, this is un minus 1. Okay, so 1 by 5 whole to the power n, and you got inside the bracket u of n minus a into 5 un minus 1. If you take here a 1 by 5, 5 will be cancelled, so you will get 1 by 5 whole power and un minus 1. But del of n, this is nothing but del of n. Oh, okay, this is nothing but del of n. So del of n multiplied by this signal, so n here n will be replaced by n equal to 0. Okay, so because del of n is non-zero only at n equal to 0, that's why so overall will be non-zero only at n equal to 0. That's why a will be equal to, because this is satisfied now, this two sides are satisfied, that's why a equal to 1 by 5. So using above result, determine the impulse response g of n of an Lti system which is inverse of previous system. So h of n, you have to find inverse of this system h of n. So suppose that system is at g of n, h of n convolve with g of n equal to del of n, where g of n is inverse of h of n. So okay, you can find this. This equation is given in previous problem. Okay, so here you can transform this equation into this. Okay, or you can do like this, you take z transform both, what you'll get h of z into g of z equal to 1. So g of z will be equal to 1 by h of z. You put here h of z, you will get. Or you can do by time domain properties, h of n convolve with this, you will get. Means this you can write this into this. Okay, it is very easy. Means h of n multiplied h of n multiplied by 1 is nothing but h of n convolve with del of n. Okay, and this is h of n convolve with del n minus 1. Take common h of n. You have to form this equation, that's why you are doing this. So you will get g of n like this. Okay, by practicing you can do by your own this all this. So okay, so these are small systems. You have to find orally whether the system is invertible, non-invertible, like this. Y of n is equal to n into x of n. N is time variant, x of n is non-invertible system. Okay, the overall system will be time variant. Okay, means these are, you can say, homework you can do by your own. Okay, impulse response term is valid only for LTI system. Okay, remember this. We already consider impulse response for only LTI systems. So determine whether each of the following statements are true or false. The cascade of uh, two non-causal LTI system with causal one is the cascade of a non-causal LTI system with causal one is necessarily non-causal. True or false? So here the statement is false, means you have to cascade two non-causal LTI system. You have to find the resultant system is causal. You have to means cascade a non-causal system with causal, and you have to find overall system is causal or non-causal. So here it is saying that non-causal, which is false, because non-causal convolved with causal will be causal. This is not necessary actually. Non-causal convolved with causal may be causal and may be non-causal. Here it is necessary. It's saying necessarily causal, non-causal. That's why system statement is false. You can conclude using an example here. A non-causal is un minus 2, un plus 2. Like it is non-zero for n less than 0. That's why it is non-causal. Del n minus 5 is causal. And if you convolve this 2, you get resultant system un minus 3, which is a causal. The system statement is false. Okay, that's enough for today. We'll continue in next lecture. Thank you. If you like, please subscribe for the next lecture, uh, and if you have any doubt related to my lecture, if I am going too fast, so please comment means your doubts, so that I will improve. Thank you.